Welcome to my channel. In this video we are going to see multiple choice question and answers in sequential circuits. When inverter is placed between both inputs of an SR flip-flop, then the resulting flip-flop is what? So actually inverter is placed between S and R input of the SR flip-flop. So the resultant flip-flop will be like this. Here we are placing one inverter in between this S and R. So in this resultant flip-flop there is only one input. Okay. So here the options are SR flip-flop, master slave flip-flop, JK flip-flop and D flip-flop. So if you are taking SR flip-flop, here there is two inputs, but here there is a single input, so it will not be a correct one. In JK flip-flop also there is two input, so it is also wrong. And in master slave flip-flop we need two flip-flops, so this option is not the correct one. The only option which is suitable for this is D flip-flop. Okay, so if the inverter is placed between the S and R input of the SR flip-flop, the resultant flip-flop will act as a D flip-flop. So the answer is D flip-flop. This comes under the topic interconversion of flip-flops. That means the realization of one flip-flop from another flip-flop. Actually, I already explained this topic in my previous video. I will give you the link in the description box. You can check it. Similarly, if you are connecting inverter between J and K input of the JK flip-flop, it will also behave like a D flip-flop. And if you are connecting, otherwise the J and K input is tied together, means it will act as a T flip-flop. Okay. What is the maximum possible range of bit count specifically in n-bit binary counter consisting of n number of flip-flops? So in a n-bit binary counter there is n flip-flops, n bits, there is n flip-flops. By means of this n flip-flops we can represent 2 power n distinct states. That means for example, if you have two flip-flops, it can represent 4 different states. That is 2 power 2, 4 different states. And that 4 different states are in the range of 0 to 3. So actually it can count from 0 to 2 power n minus 1. So the range of count is 0 to 2 power n minus 1. Whereas the maximum value of count is 2 power n minus 1. So actually this n-bit binary counter will count from 0 to 2 power n minus 1. So the answer is B, that is 0 to 2 power n minus 1. How can parallel data be taken out of a shift register simultaneously? So shift register, and we have to take parallel data. So if you want to access the data parallel, means you have to take the output of each and every flip-flop. Okay, so here the options are, first one is tie all of the Q output together. So if you are tied all the outputs together, mean you get only one output. Okay. Second one, use the Q output of the last flip-flop. So here we are taking the output of the last flip-flop only, and it's like a serial out. But here we need parallel data. Third one, use the Q output of each flip-flop. So here we are taking the output of each and every flip-flop. So we are taking the output parallelly. So the correct answer is use the Q output of each flip-flop. This is the correct answer for this question, because we are taking parallel output. And the last one is you use the Q output of the first flip-flop. It is also like a serial output. So this is not a correct one. So the correct answer is use the Q output of each flip-flop. Okay. So next one, the number of flip-flops required to design a modulo 272 counter is. So you have to find the number of flip-flops, and here the count value, that is mod value, is 272. So in modulo counter the condition is power n should be greater than n. This is the condition in modulo counter. Here n value is given, that is mod value n is equal to 272, that is which represents the total number of states, and the condition is 2 power n should be greater than n. Here n is the number of flip-flops. Your question is you have to find the number of flip-flops. That means you have to find what is the value of small n. Okay. If you are taking n is 8, you get 2 power 8 is equal to 256. Here capital N value is 272. Here 2 power 8 is 256, which is less than 272. So you cannot choose 8. Then next value is 9. If you put n is equal to 9, 2 power 9 is equal to 512, which is greater than 272. So you can take n is equal to 9. So here the correct answer is B, that is 9. The initial contents of the 4-bit serial in parallel out right shift register shown in figure is 0, 1, 1, 0. After 3 clock pulses are applied, the content of the shift register will be what? Okay. So this is a 4-bit serial in parallel out right shift register. 4-bit, so we need 4 flip-flops. And in shift register, the flip-flops used are D flip-flops. And in D flip-flop, the output is equal to your input. What is given in the input will appear at the output. So Qn plus 1 is equal to D. Okay. So here each bit represent one flip-flop. You can take first one as a first flip-flop. So the output is Q1, Q2, Q3, Q4. So write Q1, Q2, Q3, Q4. Okay. All are D flip-flop. So what is present in the input will appear at the output. And in the first flip-flop, the input is equal to exclusive R of the output of third and fourth flip-flop. Okay. So Q1, here the input D1 is equal to exclusive R of the output of third and fourth flip-flop. So Q3 exclusive R Q4, which is given as an input to this first flip-flop. So the initial condition of this flip-flop is 0, 1, 1, 0, which is given in the problem. So 0, 1, 1, 0. So now this is the initial condition. During the first clock pulse, D1 is equal to Q3 exclusive R Q4. Here Q3 is 1, Q4 is 0, 1, 0. Exclusive R of 1, 0 is 1. Because when both the inputs are different, then the output is 1. When both the inputs are same, the output is 0 in exclusive R. Here both the inputs are different, so the output is 1. So 1 will appear at the input of the first flip-flop. Here flip-flop is a D flip-flop, so output is also 1. Output is 1. It is a right shift register, so this will shifted to next. This will shifted to next bit, and this will shifted to next bit. During the second clock pulse, here Q3 is 1, Q4 is 1, they are exclusive R 1, 1. Exclusive R of 1, 1 is 0. Okay, so 0 is given as an input to the first flip-flop. So the output is also equal to 0. So 0. And this will be shifted to right. This will be shifted to right, and this will be shifted to right. So 0 here, 1 here. During the third clock pulse, here Q3 is 0, Q4 is 1. The inputs are different, so the exclusive R output is 1. That is given as an input to the first flip-flop. So output is also the same 1. So you get 1 here, and right shift. So this 0 will be shifted here, 1 will be shifted here, 0 will be shifted here. So after this third clock pulse, the state of this 4 flip-flop is 1, 0, 1, 0. Your question is the content of the shift register. The content of the shift register is 1010. So the answer is C.